Air is the very first thing we ever know. Before we see the world, before we feel touch. The first breath is the cry of life. The last is its echo. Everything that we are happens between them, in the rhythm of inhale and exhale. We breathe when we sleep, when we forget ourselves, when we dream of something else, and yet we rarely stop to think that every breath is an exchange with the planet. That what now fills our lungs may have, just moments ago, passed through the leaf of a tree, the fin of a whale, the feathers of a bird. We breathe the same air that once filled the lungs of everyone who lived before us. The lungs have no voice, but if they could speak, they would tell the story of a miracle that unfolds within them thousands of times a day. How invisible oxygen slips through microscopic membranes and, in a single heartbeat, reaches billions of cells. Each one waits for it like a spark of life. Without it, they fade. Inhale is a promise, exhale a debt. And in this endless exchange between us and the world lies the very biology of existence. But breath isn't only biology. It's the language of emotion. When we're afraid, we hold our breath. When we cry, it breaks like a thin thread. When we're happy, it flows freely, as if the body somehow knows everything is in its right place. That's why in many languages, the word for spirit also means breath. Because within each of us there is something that breathes deeper than the body. Air moves in and out of us, and we barely notice that for a moment, we are one with the world. We breathe the forests of the Amazon, the winds of the Sahara, the oxygen born in the oceans. Our lungs are the harbor where all the currents of Earth meet, and every breath is a reminder that life, though fragile, is part of something infinite. The lungs are like two trees hidden inside the chest, inverted, with their roots reaching upward. Their trunk is the trachea, which splits into two main branches, the bronchi. From there, hundreds of thousands of smaller branches, bronchioles, extend outward, each ending in tiny air sacs so small that millions could fit on the tip of a finger. Each lung holds about 300 million of them. Together they create a surface area larger than a soccer field. And it's there, in that quiet, delicate space, that the miracle happens. The exchange between us and the world. When we inhale, oxygen fills those tiny sacs. Their walls are so thin they resemble fog trapped in a membrane. On the other side, capillaries, fine as threads, wait, carrying blood from all over the body, heavy with carbon dioxide. This is where two worlds meet, what we breathe out and what we breathe in. Oxygen crosses the membrane into the blood. Carbon dioxide flows in the opposite direction. The exchange lasts only a fraction of a second, but it happens billions of times each day. The lungs don't breathe by themselves. The muscles around them, especially the diaphragm, do the work pulling air in. When it contracts, the lungs expand like sails catching wind. When it relaxes, the air is pushed out. We repeat this simple, rhythmic act about 20,000 times a day. And though it feels effortless, it's one of the most precise systems nature has ever created. Inside the lungs, there's no engine, no pump. Everything depends on pressure, the subtle difference between the air outside and inside. The lungs don't pull air by force. They invite it in. Their walls are elastic, supple, always ready to stretch and return again. Every inhale is a small explosion of life. But for the lungs to function, they rely on perfect coordination with the blood, the heart, and the brain. It's the brain, specifically a small area called the respiratory center, that decides how often and how deeply we breathe. It does this constantly, responding to the level of carbon dioxide in our blood, not to the lack of oxygen, as we might think. Carbon dioxide is the true clock of breath. And though the lungs are a symbol of life, they are astonishingly fragile. Their membranes are so delicate that if spread out on a table, they could tear under the weight of their own shadow. Yet it's precisely this fragility that makes them so effective. The power of breathing doesn't lie in strength, but in the delicate balance between tension and release, between the inside and the world beyond. The lungs are not just an organ. They are an architecture of trust. Every day, they open themselves to the world, letting in what is foreign, in the hope that among billions of molecules, there will be the one that gives us life, air that thinks. That's one way to describe what happens when breath meets mind. Each inhale is more than oxygen intake. It's an impulse that shapes our emotions, focus, and thoughts. Breathing is woven tightly into how we feel the world. It determines how fast the heart beats, how the body reacts, how the brain arranges thoughts. When we're calm, the breath is long and soft. When fear strikes, it breaks, as if afraid of its own echo. The lungs and the brain are two sides of the same melody. The brain cannot survive without oxygen for more than a few minutes. Every neuron, every spark of awareness depends on it. But it also works in reverse. What happens in the mind instantly alters the rhythm of breath. Fear speeds it up. Anger makes it shallow. Peace deepens it. Breathing, then, is not just physiology. It's the quiet language through which the brain and body speak to one another. It's no wonder that many ancient cultures saw something sacred in breath. The Sanskrit prana, the Chinese ki, the Japanese ki, all mean the same, the life force carried by air. Breath has always been more than a mechanism. It's the soul in motion. In ancient yoga practices, Zen meditation, and the prayers of monks, the rhythm of breath was the gateway to another state of consciousness. Today, science only confirms what those ancient masters already knew. Mindful breathing truly changes the way the brain works. When we slow the breath, the nervous system begins to shift. The vagus nerve, that mysterious messenger between the brain and the body, activates, sending the signal. You are safe. The heart slows, muscles release their tension, and the brain moves from survival mode to a state of sensing and feeling. That's why breath can calm panic, ease pain, and sometimes even replace words. Imagine the air suddenly disappearing. Not because something blocked your nose or mouth, but because oxygen itself vanished from the atmosphere. Your lungs would still move, your muscles would still try to pull in air, yet every breath would be empty. Because lungs cannot live on their own. Their life depends on something much greater, on the planet that breathes with us. Every breath we take begins not in our chest, but far beyond it. In the leaves of trees, in the waters of the ocean, in the microscopic organisms floating in sunlight. They are the ones that make oxygen. We only borrow it. Trees are the first lungs of the earth, visible, majestic. Within their leaves takes place a quiet miracle, photosynthesis. Sunlight, water, and carbon dioxide turn into energy and oxygen. With every exhale, we return to them what they need. And in return, they give us what we cannot live without for even a few minutes. Breathing is not just physiology. It's a conversation, a silent exchange between humanity and the world. But the most important lungs of the planet are hidden in places we can't see. In the ocean, there, drifting in the light, are tiny, transparent beings. Phytoplankton. They, not the rainforests, produce more than half of the oxygen we breathe. Every drop of seawater is a microscopic factory of life. And when the oceans weaken, when they overheat, acidify, when currents shift, the world begins to suffocate. Slowly, almost imperceptibly. The oxygen you're breathing right now might have been created in an oak leaf, in algae off the coast of Chile, or in cyanobacteria, the ancient life form that billions of years ago made the atmosphere we know possible. It was then, in those primeval seas, that breathing was born. Every breath you take now is an echo of that moment. Without trees, without oceans, without light, our lungs would be nothing but empty sacs of air, waiting for something that will never come. Because it isn't we who breathe the world. It's the world that breathes through us. Earth doesn't have a single pair of lungs. It has billions, in leaves, in algae, in every creature that draws in air. Our own lungs are simply their continuation, the echo of a planet that learned to live through oxygen. If one day we forget how deeply we depend on forests and oceans, it won't be they who stop breathing. It will be us. There was a time when air was invisible, pure. It smelled of rain, sea salt, tree resin. Today, more and more often, it tastes like metal, breathing. Something that for millions of years was the simplest act of life. has become an act of courage. Our lungs are now guardians standing at the border between body and world. They filter air that is no longer always fit for life. With every inhale, we take in not only oxygen, but thousands of particles, dust, soot, chemical fumes, microscopic bits of plastic. The invisible dust of civilization hangs above cities, in valleys, even in mountains that once were sanctuaries of clean air. Smog isn't fog. It's a cocktail of exhaust, dust, and toxins that seeps into everything. Our clothes, our hair, and finally our lungs. It reaches deep down to the alveoli, where oxygen should meet blood. Instead of life, it brings slow poisoning. Each breath becomes a conversation with a toxin. Nothing seems to happen until the body begins to rebel. Addictions only accelerate this war. A cigarette at its core is an act of trust towards smoke. We draw it in as if it were air, and it settles inside us like soot in a chimney. The lungs try to defend themselves, coating their walls with mucus, sending out tiny cilia like microscopic brooms to sweep away the intruder. But the moment comes when the defense weakens. The cilia stop moving. The tissue stiffens. It's as if a once green forest began to choke on its own ashes. Big cities have become places where breathing is a luxury. Children grow up never knowing what clean air smells like. In India, in China, in parts of Europe, wearing a mask has become an everyday ritual, a symbol of an era where technology evolves faster than awareness. But it's not just factory smoke or car exhaust that poisons our lungs. Increasingly, it's also what seems harmless: perfumes, cleaning sprays, aerosols. The air becomes a mix of scents meant to hide something, yet they fill our lungs with chemicals we barely understand. Lungs have no armor. They can't close themselves off, can't run away. They breathe everything we give them. They are like city trees, silent, filtering, enduring as long as they can. But even trees eventually wither. And there's something deeply symbolic about that. We have destroyed the air we were made from. Not water, not fire, not earth, but breath. The quietest, most fragile thread connecting us to the world. We often see lungs as an organ, but they're also a story about relationship, about how humanity forgot that it breathes with the planet, not against it. Every puff of smoke, every factory chimney, every burning forest is not just another statistic in a climate report. It's a wound in our own alveoli. Lungs are like an ocean after a storm. Even when the waves are violent, the water always tries to return to calm. So do our lungs, day after day, breath after breath. They are among the few organs that truly know how to heal. Inside their tissues lies both memory and forgetting. They remember damage, but they also know how to erase it, given the chance. Every inhale sets off millions of microscopic motions. Cilia waving like fields of grass. Cells clearing dust, bacteria, particles of smoke. When we stop smoking, when we breathe cleaner air, those cilia come back to life. They move again, cleansing the walls of the bronchi, restoring order in a world long coated in soot. Within weeks, oxygen levels in the lungs rise. Within months, scars begin to fade. And after a few years, studies show the risk of disease almost returns to that of someone who never smoked. Lungs are like a forest after a fire. It looks dead, yet beneath the ash, new life begins to sprout. The epithelial cells of the airways can divide and rebuild alveoli, even in adults. When one region is damaged, others take over its function. It's a rare ability. Most organs never get a second chance. But lungs don't heal in silence. They need a world that allows it. Air free of toxins. Movement that stretches the chest and fills every alveolus. Moisture to keep their membranes from drying. Even a simple walk in the forest can be therapy. In air filled with essential oils and negative ions, the lungs seem to work more peacefully, as if they were finally breathing for real. Nature also gave us what might be called a reserve of breath. The human lungs contain far more alveoli than we use daily. Most stay dormant, opening only when truly needed, during exertion, deep breathing, or laughter. That's why laughter, as trivial as it seems, is one of the simplest forms of breathing exercise. Yet some wounds are not easily forgotten. Scars from chronic smog, years of smoking, or illnesses that left their mark. Even then, the lungs keep fighting, rerouting their pathways, reorganizing tissue, still delivering oxygen. A quiet, invisible heroism every minute. We take 10 to 20 breaths, unconsciously. And with each one, the lungs choose life, despite pollution, stress, air conditioning, despite everything we do to them. It's not a miracle. It's the consequence of billions of years of evolution. Because lungs remember not only smoke and dust. They remember clean air, the blue sky, the ocean wind. They know what health feels like. They just need to be reminded. Sometimes all it takes is to pause, take one deep, conscious breath, and let them do what they were made to do. Because lungs, more than any other organ, believe in second chances. Once, air was something we never thought about. As obvious as the sky itself, now it's becoming both a luxury and a challenge. In some cities, breathing pure oxygen is no longer a metaphor but a service. Oxygen bars, filtered air capsules, masks that are not fashion but necessity. A paradox. The same species that learned to fly and reach the stars must now question what it's actually breathing. If the future has a scent, it will be the scent of filters. The air that once came freely from nature will more and more have to be made. Purified, cooled, enriched with oxygen. Even now, smog filtering towers are being built, acting as artificial trees. In China and the Netherlands stand prototypes of such city lungs, drawing in thousands of cubic meters of air a day, turning toxins into fine dust used to make jewelry. In laboratories, scientists design algae and moss that can process carbon dioxide faster than plants, creating oxygen in closed spaces. Researchers are working on buildings that breathe, walls coated with living microorganisms that filter air, ventilation systems responding to CO2 levels in real time, even oxygen houses where air changes quality depending on the hour, stimulating in the morning, soothing at night. Breathing will become a design element, a part of architecture itself. But the future of breathing is not just about technology, it's also about the limits of human adaptation. Even now, our lungs are slowly evolving. Children born in high altitudes have more red blood cells, while city dwellers learn to live with higher carbon dioxide levels in their blood. Evolution, though slow, continues. Perhaps thousands of years from now, humans will breathe differently, more efficiently, with less oxygen loss, maybe even aided by biotechnological implants enhancing lung performance. Some futurists predict that one day we'll stop breathing air as we know it, in the sealed cities of the future, floating above the Earth's surface or buried beneath it. The atmosphere will have to be recreated artificially, and in space, where there is no air at all, humans are already testing systems that recycle breath. Every exhale becomes the source of oxygen for the next inhale. Breathing will become a survival technology, but it might also, as inventions often do, become a reason for reflection, because only when we start producing oxygen in laboratories will we understand what an unimaginable miracle it was that trees did it for free. The future of lungs doesn't have to be catastrophic. It can also be full of hope. Because the more we learn about their fragility, the more we appreciate their strength. They're the only organ that constantly connects us to the world. Literally, physically. Every breath is an exchange between us and the planet. If we understand that the oxygen we inhale was born in the ocean and in the leaves of trees, maybe we'll start caring for them the way we care for our own lungs. Imagine your body stops breathing, yet you remain alive. The heart beats, the brain works, the blood flows, but air no longer enters or leaves the lungs. In nature, that's the end. But in modern medicine, it can be a pause, a moment suspended between life and its loss. Because humans have built a machine that can breathe for another human. It's called ECMO, extracorporeal membrane oxygenation, a device that replaces the function of the lungs, and sometimes even the heart. It works like an artificial lung. Blood is drawn out of the body, pass through a membrane that removes carbon dioxide and saturates it with oxygen, and then return to the body. All of it happens outside the lungs, silently, precisely without a single breath. ECMO is the last line of defense, used when the lungs have no strength left. In newborns with respiratory failure, in burn victims whose alveoli have turned into dead fields. Thanks to this technology, doctors can buy time for recovery, for transplant, for the miracle of biology. But ECMO isn't the only way humans have learned to borrow oxygen. Ventilators, machines that push air into the lungs through a tube, are now standard in intensive care units. Their history goes back to the early 20th century, when the idea was as simple as it was brilliant. If the respiratory muscles fail, a machine can replace them. The first iron lungs, huge metal cylinders that enclosed the whole body of a patient with polio, looked like metallic coffins, yet they gave life to thousands. Today, they're miniature, precise, computer-controlled, capable of simulating every nuance of natural breathing. Technology keeps moving forward. Scientists are working on bio-artificial lungs, built not from metal and plastic, but from living cells. In laboratories, fragments of lung tissue have already been grown that can exchange gases like real alveoli. In the future, such organs could be grown from a patient's own cells, eliminating the problem of rejection. Miniature, portable breathing assist systems are also being developed, small as a backpack, allowing people with respiratory failure to live almost normally, to breathe without hospitalization. The goal is simple, that a person can keep experiencing the world even when their own lungs are silent. And yet, despite all these inventions, one thing remains unchanged. No machine can replicate the true rhythm of life, because breathing is more than the movement of air. It's emotion, stress, calm, sleep, laughter. It's something that reacts to touch, to thought, to fear. Artificial lungs can keep the body alive, but they cannot give it what matters most, the feeling of breath. And maybe that's why, even though we can build a mechanical heart, a synthetic brain, and even lungs made of glass and steel, we still dream of one thing, that our own fragile lungs last us as long as possible. Breathing seems simple until we try to stop. Just 1 minute without air, and the body begins to panic. 2 minutes, the heart races, the brain sounds the alarm. After 3 minutes, oxygen in the blood starts to run out, and neurons, the most delicate of cells, begin to die. 5 minutes without breath is the limit for most people. But there are those who have pushed it further, into realms that seem impossible. The world record for holding one's breath without oxygen assistance is over 11 minutes with oxygen, nearly 25. It's not a miracle, but biology pushed to the extreme. Freedivers trained to slow their hearts, lower their oxygen demand, almost put the body to sleep. Their muscles start consuming less energy, and blood flows away from the limbs to protect the brain and heart. It's an ancient reflex, called the diving reflex, shared with seals and dolphins. All it takes is for the face to touch cold water, and the body itself begins to fight for survival. Calmly, methodically, as if remembering that once, long ago, water was our first home. But the deeper we go, the harder it becomes to breathe. And not just because of the lack of air. Water is dense, and pressure increases with every meter. At 10 meters deep, the body experiences twice the pressure of the surface. At 30, 4 times. It's as if all the water in the world tried to force the air back into our lungs. Oxygen and nitrogen. Normally, our friends become treacherous in such conditions. Nitrogen starts acting like a narcotic. Divers call it rapture of the deep, a state of euphoria, hallucination and disorientation, and oxygen, in excess, becomes poison, damaging nerve cells. A paradox of nature: the more oxygen, the greater the danger. High in the mountains, the situation reverses completely. There, the air is thin, too light and rarefied to supply enough oxygen to the body. At the summit of Mount Everest, oxygen concentration is 2/3 lower than at sea level. Every breath is a struggle for survival. The heart races, breathing quickens, yet the body still hungers for oxygen. Over time, the body learns to adapt. Red blood cell count increases, the blood thickens, and the lungs work at their limits. That's why mountaineers say that up there, every breath feels like the first and the last at once. But there are people who have lived there for generations, the inhabitants of the Andes, Tibet and Ethiopia. Their bodies have adapted to altitude. They have larger lungs, more capillaries, a different heartbeat. It's the result of thousands of years of evolution teaching them how to survive, where others would suffocate in minutes. And it's not just humans walking the edge of breath. Animals are masters of it. A whale can dive over 3 kilometers deep, holding its breath for more than 2 hours. Its lungs hold less air than ours. The key is in its blood, enormous concentrations of hemoglobin and myoglobin that store oxygen like batteries. Penguins can shut down entire parts of their bodies to save energy. Sea turtles in cold water can slow their metabolism so drastically that they don't need to breathe for hours. Humans can't match them underwater. But we have something else: awareness. We can control our breathing, slow it down, use it in meditation, in sport, in pain. Breathing is the only vital function we can consciously regulate, and that's what makes it so unique. It's the point where biology meets will. Maybe that's why anyone who has ever sunk into the silence beneath the water, or stood on a mountaintop where the air is thin as glass, knows that breath is more than survival. It's the purest form of life. Not every breath is the same. For most of us, air is obvious, transparent, light, always there. But high in the mountains where the air becomes thin as glass, every inhale is a struggle. Oxygen, abundant at sea level, disappears there. It thins, fades, escapes with every gust of wind. A climber knows this from the first step. At 3,000 meters, the body starts to rebel, the heart races, the head throbs, muscles weaken. These are the first signs of hypoxia, oxygen deprivation, and that's only the beginning. The lungs try to compensate. They breathe faster, deeper, harder. The heart pumps blood furiously, trying to deliver what little oxygen there is, but it's not enough. Only after a few days does the body start learning a new rhythm. The kidneys expel more carbon dioxide to change the blood's chemical balance. The bone marrow produces more red blood cells, carriers of oxygen. Hemoglobin levels rise, allowing it to hold on to oxygen more tightly. Over time, a person begins to breathe like someone who has learned to dance in the shadow of air. But the lesson comes with pain. Altitude sickness can break even the best trained climbers. Headaches, vomiting, hallucinations, swelling of the lungs and brain, all because the body can't keep up with change. That's why mountaineers train for years before facing great heights. For weeks they acclimatize in camps, moving up a few hundred meters at a time. Their bodies learn to survive where humans were never meant to exist. And yet beside them, along the same paths, walk those who have done it for generations, the Sherpas, the sons and daughters of the Himalayas. They carry oxygen tanks, tents, gear, sometimes the climbers themselves, without masks, without apparatus, without escape. For them, the air at 5,000 meters is different, but not hostile. Their lungs are larger, their hearts stronger, their blood carries more hemoglobin, and their capillaries are denser, as if nature itself drew a map of survival within them. It's not training, but evolution. For thousands of years, their bodies have adapted to life where others can barely catch a breath. Scientists have discovered that the genes of Sherpas contain a variant inherited from an extinct species of human, the Denisovans, which help them adapt to low oxygen levels. It's not a myth. In their DNA lives the memory of ancient humans who survived through a different kind of biology. Climber from the West may train his whole life, But when he stands beside a Sherpa, the difference is clear. He fights for every breath, while the Sherpa breathes calmly, as if the mountain were his home. It's not just muscle strength. It's the quiet of a body that doesn't see altitude as a threat. The paradox of altitude is this: the higher you climb, the more you must learn humility. Mountains don't reward bravery, they reward patience. Lungs, which in the valleys are tools, up there become the measure of humanity. Every breath is a choice, a decision to go on. Air is something we never see, yet it's present in every second of our lives. As long as it's there, we don't think about it. But when it begins to fade, the world slows down, the body grows silent, and every breath becomes effort. The lack of oxygen doesn't strike suddenly. It's a slow fading of sound within the body. When air grows scarce, the brain reacts first. Within seconds, its cells switch into emergency mode. The heart races to deliver more blood. The lungs expand, trying to catch something from air that no longer gives anything. But oxygen is what fuels our inner fire. Without it, the energy in our cells begins to die out. Muscles fill with lactic acid, the brain with fog, the heart with panic. You see it most clearly in water. When a person loses air, the body instinctively holds its breath. But that reflex lasts only a moment. After several dozen seconds, an overwhelming urge to inhale takes over. It's not the lack of oxygen that causes it, but the buildup of carbon dioxide. It's CO2 that tells the body, breathe. Then the person opens their mouth, and the lungs, instead of air, draw in water. That's what becomes the barrier between life and its absence. Paradoxically, it's not water that suffocates, but chemistry. Cells trying to breathe in a world where oxygen no longer exists. A similar drama unfolds in fire. In a burning room, heat isn't the first enemy. Oxygen loss is. Fire devours oxygen instantly, within seconds. That's why people in smoke-filled spaces don't faint from the smoke itself, but from lack of air. The remaining air fills with carbon monoxide, oxygen's silent rival. When it enters the bloodstream, it binds to hemoglobin 1,000 times more strongly than oxygen, blocking its transport. The blood keeps flowing, but it's useless. That's why firefighters wear oxygen tanks, not just to avoid smoke, but to truly breathe. Smoke hides another problem. Soot and toxic particles sink deep into the alveoli, irritating and damaging them like sandpaper. Lungs, soft and delicate like sponges, begin to swell, and their gas exchange surface shrinks. With every breath, the body works harder to gain less oxygen, like trying to breathe through glass. But the absence of oxygen isn't always tragedy. Sometimes it's a teacher. The human body can adapt within limits. That's why freedivers can stay underwater for minutes, and mountaineers can live for weeks at altitudes where air is only a shadow. Their lungs, muscles, even their brains learn thrift. The brain can lower activity in some regions to protect the vital ones. It's a hierarchy of survival. Oxygen first for the heart, then the head, then the rest. Even more astonishing, some organisms do this far better than we can. Scientists have discovered turtles and fish that can survive for months in water almost devoid of oxygen by entering a state like hibernation. Their cells produce only minimal energy, just enough to maintain their structure. When oxygen returns, life resumes as if nothing happened. For humans, that remains impossible. But perhaps the future of medicine lies there, in understanding how some creatures can live without what, for us, is everything. Lungs are not just two balloons that fill and empty. They are one of the most extraordinary organs in the human body. Dynamic, self-regulating ecosystems that perform over 20,000 breaths a day, filtering around 10,000 liters of air. Behind that simplicity lies a series of marvels. Though hidden in the chest, lungs aren't symmetrical. The right has 3 lobes, the left only 2. Why? Because on the left, the heart had to make space for itself. A subtle agreement between 2 of life's most vital organs. If all the alveoli were spread flat, their surface would cover about 70 to 100 square meters, larger than a tennis court. And that surface determines how much oxygen passes into the blood every second. Each breath isn't only oxygen, it's sound. As air flows through the lungs and airways, it creates vibrations. That's where voice begins. Without lungs, there would be no laughter, whisper, or song. They are the instrument on which our vocal cords play. In a way, every person is a musician, and every breath, a note. Lungs also have a remarkable power of self-cleaning. Their inner walls are lined with tiny moving cilia that sweep mucus like microscopic oars. In a single day, these cilia perform millions of coordinated movements, pushing out impurities toward the throat. Thanks to them, dust, bacteria, and particles never reach the bloodstream. They're expelled, usually without us noticing. Interestingly, this mechanism works best when we breathe through the nose, because the nose warms, filters, and moistens the air. Mouth breathing is a shortcut the lungs later have to fix. And did you know lungs have their own bacteria? For a long time, scientists believed they were sterile, but research has revealed the existence of a lung microbiome, a delicate community of microorganisms that cooperate with the immune system to protect us from infection. It's a microscopic world living in symbiosis with us, changing as our environment changes. Even more surprising, lungs help create blood. For decades, it was thought that only bone marrow did that. But in 2017, researchers discovered that millions of platelets are produced in the lungs every day. It's as if the organ of breathing were also part of the system of blood itself, connecting two worlds, oxygen and life. When we sleep, the lungs don't rest. Their rhythm slows, but never stops. Interestingly, our breathing is never perfectly even. Sometimes it deepens, sometimes it flattens. That's because breath is tied to emotion. Fear, calm, awe, anger, each changes its rhythm. In a way, the lungs are our most sensitive emotional barometer. And now something that may sound like a paradox. The lungs don't actually like air that's too clean. In laboratories, scientists have found that a completely sterile environment can weaken their ability to respond to microorganisms. Evolution designed them to live in a world full of particles, scents, dust, and bacteria. That's why children who grow up in the countryside, surrounded by dirt, plants, and animals, often have healthier lungs than those raised in perfectly clean cities. The lungs are an organ that doesn't hurt. They have no pain receptors, so when they fall ill, they don't scream. They whisper. Their warnings are subtle. Breathing becomes shorter. Deep inhalations are harder. There's coughing, or a feeling of heaviness in the chest. Sometimes it's just a cold. Sometimes it's something far more serious. One of the most common and well-known diseases is pneumonia. That's when the tiny alveoli, the microscopic chambers of gas exchange, fill with fluid instead of air. Imagine trying to breathe through a wet cloth. Air can't pass. Oxygen doesn't reach where it should. The body tires even from simple movements, as if every step were a climb. Pneumonia can take many forms. Sometimes it's caused by bacteria, sometimes by viruses, and sometimes by inhaled toxins. It often follows a common cold, when the immune system weakens and inflammation begins to grow in the lungs. The body fights back with fever, cough, and chills, trying to drive the invader out. Doctors talk about crackles in the lungs, the sound of air forcing its way through fluid-filled alveoli. Throughout history, pneumonia has been feared. It was once called the old man's friend because it often struck the weak, bringing a quiet end to their journey. Today, antibiotics and modern medicine can defeat it, but it remains one of the most serious respiratory infections. Yet infection isn't the only thing that disturbs the peace of the lungs. The modern world has created a new category of illness: the diseases of civilization. Smog, cigarette smoke, industrial dust, all of it enters our airways every day. Over time, the tiny cilia that should clear the debris stop working. Then comes COPD, chronic obstructive pulmonary disease, an illness that literally steals space from breath. Every inhalation becomes a struggle for air. Another silent condition is asthma. Though it often begins in childhood, it can stay for life. It's a hypersensitivity of the airways. The muscles around the bronchi tighten too strongly, narrowing the passages where air should flow. During an attack, an asthmatic feels as if the breath itself were being squeezed into smaller and smaller tunnels, as if air no longer fit inside the body. The attack may last only seconds, but its memory lingers for years. There's also pneumoconiosis, the miner's disease, caused by years of inhaling coal dust and rock particles. These tiny grains settle deep in the lungs, leaving irreversible scars. The tissue grows stiffer, less elastic, less able to exchange gases, each breath heavier than the last. Pneumoconiosis is a testament to how work and environment can leave permanent marks on the human body. And then there are the hidden illnesses, like lung cancer. It develops in silence for years, showing no signs, only when the lungs lose their ability to clean themselves. When the cough becomes persistent, when the breath begins to sound different, only then does the body signal that something is wrong. It's one of the most deceptive diseases, often discovered too late. Yet despite all these dangers, the lungs have the power to heal. If we stop smoking, if we breathe clean air, if we move our bodies, the cilia begin to stir again, the mucus protects again, oxygen flows more freely. The lungs are like an ocean after a storm. They need time to calm their waves, but they always carry within them the ability to return to balance.